Alright, in the first case we're looking for an adjacent side is the AB. So this is the adjacent side. So if you're adjacent, you are directly beside the angle. So you must be this angle here, angle B. Remember, if you have an angle a reference angle, and you touch the arc between that, you'll always touch the adjacent and the hypotenuse. This is the hypotenuse, this is the adjacent. Down here it asks for the sine ratio of angle B, which is the opposite to the hypotenuse. So if this is angle B, again, this would be your adjacent and your hypotenuse. This makes your opposite 15/17. This would be the ratio of sine ratio of opposite to hypotenuse. Let me set these up again. My technique is to simply make an arc on the reference angle. You'll always touch the adjacent and hypotenuse. So in this case it's a cosine question of 53 is the opposite over the hypotenuse. Here again I'll do my arc. There is my H and my A. That makes this the O. This must be a tangent question because I'm looking for an opposite, which is 16, and an adjacent, which is 6. Finally, we'll do it one more time, and we get our adjacent and our hypotenuse. Once again, this is a cosine question of 33 is 6 over x. Now, in each of these cases, you'll do it a little bit differently. You will multiply, in this case, you'll multiply 30 times the cosine of 53. And let me quickly do that. So that is the cosine of 53 times 30, and our answer becomes 18.05. Here, when you're solving for an angle, you always use the inverse function, so inverse of 16 over 6, and so second tangent, 16 divided by 6, we get 69 degrees, 0.44. And then finally here, when you are dividing by an x, what you're going to do then is, when it's in the denominator, you're going to divide. So you're going to take 6 and divide it by the cosine of 33. So 6 divided by the cosine of 33 is 7.15. Okay? In this case, they help you by drawing the diagram to show you where the angle of depression is. But ultimately, you can move that 12 down here, and then they want you to find the height of the lighthouse. So this is actually a tangent question. Tangent of 12 degrees is the lighthouse opposite over the horizontal distance, the adjacent. Again, as mentioned in the previous question, because x is in the numerator spot, we're going to just multiply these. We're going to multiply the tangent of 12 times 80, and this will give us our answer. The tangent of 12 times 80 gives us 17.00, actually, is the height of the lighthouse. Here, the nice thing is they helped us by converting them into inches, so we have the same measurement. I just think that makes it so much easier. Shadow's 36, her height is 71. We're looking for the angle that the rays hit with the ground. So this is a tangent question as well because the opposite is 71, the adjacent is 36. Anytime you're finding the angle, you will always use the inverse, always. That's the only time you use it. And so when we hit second tangent of 71 divided by 36, we find out that that angle is 63.11. In this case, it takes two calculations to get our answer. 24 is the height here. They give us a 38 down in this spot, 63 looking up at this spot. We'll call this height y. What we're going to do is we're going to find what I'll call x, will be the distance between the buildings. So again, this will be a tangent question. The tangent of 38 degrees is opposite over adjacent. Notice that the x is in the denominator. So our answer becomes 24 divided by the tangent of 38. So let's do that. 24 divided by the tangent of 38 gives us 30.72 basically. Now that allows us to set up the next triangle, which also will be tangent. The tangent of 63 is y over that 30.72. Now in this case, y is in the numerator, so we're going to multiply these two numbers to get our solution. So the tangent of 63 times 30.72 gives us 60.29. Now that's the y value, that's this part of the building, but we already know that we were 24 feet up to begin with. So we're looking at 84, and I think it says to the nearest meter. So 84 meters tall is that particular question. The cast rule tells these stories, so let me set that up for you. This says which quadrants are we in. So let's look at the cast rule. So we are negative for sine, so we have to be in these two quadrants, 3 and 4. Tangent's positive, so we are in 1 and 3. Cosine is negative, so we are in 2 and 3. That's how easy that is. Cast rule tells who's positive where. Alright, in this case, we have to figure out the reference angle. The reference angle of this is 30. This is 60. This one's 45. Reference angle is distance to the x-axis. Next thing we have to determine is whether the original value was positive or not. So cast tells us that sine in this quadrant, because 210 would be in this quadrant, is negative. So we need another time when sine is negative, which would be down here, with that reference angle. So the answer to that would be a 30-degree angle down here, which is 330 degrees, because that'll put us in a quadrant that's negative, and it will have a reference angle the same as 210. In this case, of course, 60 degrees is in quadrant 1, so it's positive. We need another time when sine is positive, which is in here, and so we need a reference angle of 60 in this quadrant, which means 120 would be the magical answer. Here, 135 is in this quadrant, which is positive for sine, so we want to be in this quadrant, and so 45 would be just the value there. So use cast as well as the reference angle to solve those. So 60 is a reference angle, so we can just look that up on our chart, and we find that the sine of 60 is root 3 over 2. This is a reference angle of 45, and so we're looking for the cosine of 45, which is root 2 over 2. It's root 2 over 2. And in that quadrant, sine is the only positive value, so cosine will be negative in that quadrant. Here, 60 degrees is a reference angle, so we're just looking for the tangent of 60, which is root 3, and it will be positive because we are in quadrant 1, where all things are positive. So this answer, and this answer. This is also a nice flashback to the cast rule. So it says cosine is negative. Now cosine is negative, let's see, here and here. But sine has to be negative, so sine is negative here and here. So we must be in this quadrant where sine and cosine are both negative, so quadrant 3. Here it says tangent is negative, so that means we're in either quadrant 2 or we could be in quadrant 4. Cast rule tells us everything about positive and negative values. Here we're coming up with equations. So the amplitude is 2, so 2. These are all sine, 2 sine. The period length is 90, which means that they get 4 of them in 360. So remember how we put the 4 there. Next one says we shift to the right by 90. So that would be right would be negative, and you could put 90 here or the pi over 2. I'm going to put pi over 2. And it's been reflected. And so reflection means a negative out here. Finally, let's try one more. A quarter of it shows up in the 360, so that would go in this position. And it has an amplitude of 4. So I think that's our guy there. Amplitude of 4, 1/4 of it in 360, and that's it. Those are our equations. So we know it's a sine curve. Let's take a look at it here. Its amplitude is 2, we can see that. And it looks like a normal b value, 2 pi. And so we moved to here, so that means we moved, we moved x minus plus pi over 2. We moved to the right by 90, and you could put plus 90 there, and then down 2. So you can see that this point here we went down 2. You can see we went right 1 increment. Things got doubled. I'm actually going to add one more thing, a negative here. Now you might say, why is that negative? Notice that the sine curve where it got moved to doesn't start on its way up, starts on its way down. Sine curves are supposed to start on the way up from that key first point. So the negative has been applied to go down first. So the negative tells us there's been a reflection over the x-axis. The 3 tells us that it's been expanded by 3, or the altitude is 3 times. The 4 tells us that there are 4 in 2 pi, or in 360, it happens 4 times. And then the last 4 means that things went up 4. So each thing got explained there. It got reflected, expanded 3 times, dilated by 3 to the x-axis. The 4, the b value of 4 means that there are 4 in 2 pi. It got contracted basically, and then the last 4 means we went up 4.